Excellent. So let's go ahead and get started. So thank you for joining to talk about what's new in Unity Catalog. You've got myself, Paul, and you've got Mert here, and we're both part of the product team at Databricks, where we're responsible for building out Unity Catalog. And what we wanted to do in today's session is to have a look at a bunch of the features that we've built over the last 12 months, and some of the upcoming new features that we're super excited about as well. Before we get into the content, just wanted to issue the standard disclaimer that some of the features that you see today might change in format before they reach your laptops. I thought it'd be really fun to start with a really short history lesson of how we got here as an industry, and have a look at the different data architectures that we've been through and how they've either helped or hindered our governance practice. So we started with a data warehouse. We loved it for many reasons. We had great SQL support. We could do historic analysis, great support for structured data. And from a governance perspective, it set us up reasonably well, right? We had things like ABAC, which gave us at least table-level access control and a very decent auditing story as well. On the negative side, it was only governing our structured data. So I give a overall B- score for our governance here. But then came the cloud data lake. That was good for a number of reasons. We got Python, we decoupled storage and compute and realized those cost optimizations. And we also had support for unstructured data and machine learning as well. But from a governance perspective, it was actually a really big step back, right? And I'll give a couple of examples here. So the first one, you had to maintain a separate data warehouse in most instances. So you didn't have all of your users there because your users who were doing SQL and BI were in your data warehouse. And then the second thing, the term swamp is often leveled at the data lake. I wanted to give one really acute example of this, and this is a real-life example of a Hive Metastore implemented on a production data lake. Okay, so people had piled files into S3, registered that as metadata in this Hive Metastore, and you can see these different schema names that are coming up because there's no governance or control over the different metadata that people can create. So you've got things like Clara Test and Abby Temp in your production data lake. So then came the lakehouse. We like the lakehouse because we've got all of our languages in there, we've got all of our data, all of our data consumers, and we can do AI and Gen AI there as well. And the pitch I'll make to you, I won't give us a score for the lakehouse yet, but this is the ideal setting for governance. Because unlike the data warehouse, we have all of our data in there, and unlike the data lake, we have all of our users in there. So we really think that this is the ideal setting for governance. And what we wanted to go through today are the kind of big feature pillars that we think we can help you realize this potential. So today's topics, we're going to go through these three different types of capabilities. So access control for data and AI. But governance is so much more than just about controlling access to data. It's also about making sure the right people get access to the right data and can understand that data and ultimately trust it as well. So we're going to go through search and discovery and lineage. So this time last year in this session, I put up the following diagram. And this is a depiction of the typical ingestion through to consumption lifecycle through your medallion architecture. And we talked about all of these different types of objects that Unity Catalog had that allowed you to implement this architecture. So things like external locations that allow you to manage access to cloud storage, these foreign catalogs in the name of Lakehouse Federation, where you can actually register these external systems like Postgres and Snowflake and Redshift in your Unity Catalog instance. And then all of these different types of objects in the middle, the tables, the functions, the models, and the volumes. And essentially, we have a really easy way to manage access to all of these. We went through this last year. You have this ANSI grant SQL statement. And I can simply say, grant select to a table to Mert or give him execute on a model. And wherever he goes in the platform, those grant statements will be adhered to. I wanted to give a couple of quick updates to this diagram. So really quickly, the row and column level access control we've seen great uptick, good use by this by customers. It's going GA, which is really exciting for us, as is Lakehouse Federation that Matej talked about earlier. So both of these features are the last ones on the previous slide to go GA. So we're really excited about that. But I wanted to chat about a couple of new object types that you may not know about that we've added in the last 12 months. So the first one of these, for those of you who come from the data warehousing world, you'll be more familiar with this. This is the materialized view. And really the aim of the materialized view is to simplify your ETL and ingest into your lakehouse and accelerate your queries against those objects. So here's how it works. You write a SQL statement like the one on the screen here, which, if you notice, is just one word different than that of creating a regular view. But we're actually going to pre-compute the results in the background. And so the results of the queries against this are going to be much more performant. And the other thing, when we do that pre-computation, we actually play a lot of tricks in the back end to make it a super efficient ETL process. So we play tricks like doing incremental ETL just all on your behalf after you write the SQL statement. The cousin of the materialized view is called the streaming table. This is something that wasn't in the data warehouse, but you get a simple DDL statement, like the one you see on the screen here, that allows you actually just create a table and start loading in data from Kafka and Kinesis and Event Hub, or even just listen to files streaming to S3 or your cloud storage system. And again, we're making all of the ETL behind the scenes super efficient, doing incrementalization and all that kind of good stuff. So these are two objects you should go check out. It makes ingesting data into your lakehouse really easy and the queries against them really performant. I wanted to switch over and talk about the Gen AI side of the world as well. So a couple of objects that we introduced this year. The first is actually a vector index. So you have the ability to take one of your delta tables and turn it into a vector index. Vector indexes have really grown in popularity because they're great at doing document lookup in RAG in your Gen AI application. So if you need your application to actually find some extra context and return that before it makes its suggestion, then this is a really great way to do it. And you get a simple UI like you see on the left-hand side of the screen here to basically turn that delta table into a vector index. And the cool thing is it will continue updating as the delta table updates as well. So it's a really neat feature. Secondly, we have the ability to create online tables from your delta table. So here we have a gold delta table. And remember, delta is this column-oriented analytical format, really good for querying, doing analytics against. It's not so good at doing high-velocity point lookups, right? And you really need that when you're doing feature serving in an ML application. So let's say that you're building a fraud application that predicts if Paul's going to be a fraudster or not. You need to grab the attributes of Paul to make that prediction. This is what the online table is really good at because it's row-oriented. So this is another one of the Unity Catalog features that's helping you with your AI applications. Okay, I wanted to introduce one new concept before we do the first demo of the session. And that's Hive Metastore Federation. So we already talked about Lakehouse Federation, which is the ability to pull in data from Postgres and Snowflake and the like. You might guess it, Hive Metastore Federation is the ability to pull in objects from your Hive Metastore. So I wanted to talk about how it works and the different use cases you can achieve by it. So here's your trusty Hive Metastore that maybe you've been using for the last 10 years or something. It's got a bunch of tables in it. What you can do is just register that as a federated catalog, federated Hive Metastore in Unity. And it creates what we call this federated catalog you see in this middle layer here. And what this means is that Unity Catalog will automatically crawl all of the assets that are in your Hive Metastore and populate that into Unity. And then simply, you can apply all of the Unity ACLs and access controls and a range of other benefits. And if you point your workloads at this federated catalog, then they'll all be respected. So the first use case for Hive Metastore Federation is actually as a migration tool. It's a really easy way to just get quick access to all of your assets in Hive. Okay, so that's use case number one. Use case number two is a little bit more nuanced, but it actually provides a great interoperability layer. So what I mean by this, we realize that you may be working with other teams in your organization, and maybe your established way of working with them is through a Hive Metastore. And you might not have control over the technology they use. You think it would be good for them if they use Databricks and Unity, but they're using Presto and Hive, so what are you going to do? So Using Hive Metastore Federation, you can continue to use the Hive Metastore as your interoperability point between the teams. If they write a table into there, then you immediately get access to it in Unity Catalog with nothing you need to do. And we actually support writes in this version of Federation as well. So if you write into this federated catalog, then we'll actually create that object back in the Hive Metastore. So in this example, that other team will be able to see the assets that you create as well. So it provides this really great interoperability layer. I'm going to pass over to Mert now to do a quick demo of Hive Metastore Federation in action.
Awesome. Thanks, Paul. So Hive Metastore Federation may seem complicated, but I'll do a quick demo just to show how easy it is. So I'm in a Databricks workspace right now, and you can see my tables are registered in my internal Hive Metastore here. And because they're Hive tables, I don't get all the great benefits of Unity, such as lineage, insights, data quality. So I'm going to quickly federate this into Unity so I can start using all those great things. So the first thing I'm going to do is I'm going to just grab the S3 bucket path where these Hive tables are stored. And you'll see I'll be using this later on. So I'm going to go to the external data section. And the first thing I'm going to do is create a connection so that Unity can access my Hive Metastore. I'm just going to call it HMS internal, and then pick Hive Metastore as the connection type, and choose an internal connection. And just in a couple clicks, I've successfully connected to my Hive Metastore. And now I'm going to federate this as a Unity catalog. So I'm going to click Create Catalog. I'm just going to call it Hive as Unity. And then paste in my authorized paths, the S3 bucket, where all these tables are stored. Cool. So just in a couple of clicks now, you can see I have my Hive as Unity catalog, which is a mirror of my tables registered in Hive Metastore. And with all these tables, I get all the great benefits of Unity. So I can go in and apply the Unity permissions for access control. Once users start using these tables, I can see the lineage and insights for them come up. And what's even better is I can apply fine-grained access control from Unity on these Hive tables. So when users come in to query them, it's enforced. So I'm going to go in just to the sample data tab, and I see there's this name column, and it has some potential PII. So I'm just going to quickly apply a masking function so that regular users can't see this potentially sensitive data. So I'm going to choose a really simple masking function that I've already created, and I'll show you what exactly it does. So it checks that if I'm a member of the account group called PII viewers, it'll show me the column. Otherwise, it'll mask it. So I'm just going to add this to my federated HMS table. And just like that, my column mask has been applied. And so I'm not a member of the PII viewers group. So if I now refresh the screen and go into sample data, you see the values are now masked. Cool. So just in a few clicks, I was able to create a connection from my Hive Metastore, federate it into Unity, and start getting all the benefits of access control, even fine-grained access such as column masks and row filters. And now all queries that come in will be audited, lineage, insights, all of it will be generated just like it was a native Unity table. Cool. I'll hand it back over to Paul to talk more about our access control roadmap.
We think it's awesome too. Okay, so we're going to finish off our chapter on access control, and we're going to talk about a few new topics. The first one of these is attribute-based access control that I'm super excited about. So the way you should think about this is the ability to specify high leverage policies that act over wide ranges of your lakehouse tables and other assets such as models. And this is going to be augmented by lakehouse monitoring that can actually do automatic classification. So for example, it can find all the PII in your lakehouse. I wanted to look at 3 very concrete examples of ABAC in action. So the first is like the canonical ABAC example. And in this use case, what we want to do is mask all columns tagged PII. And the way you would do that today is you would have to go and apply a mask to all of these tables individually, which isn't incredibly scalable. What you'll be able to do in the future is actually design a rule like the one you see on the screen right here. And this takes this catalog called turbine prod, and it applies this masking function when the column is tagged PII, which you see in the last line there. So this is one rule that's going to protect all of these different tables. ABAC use case number 2, a little bit different. This time, I want to grant temporary access to all of the models in a particular schema to a group called the Tiger team just for 90 days. Right? I'm going to assemble this Tiger team, they're going to use these models, and then they should not have any more access. So what would you do today? Well, you would grant, you would sleep, and then you would revoke if you remember to do that. What you'll be able to do in the future is actually design a rule that takes a date as one of the inputs. So you'll be able to target this schema called ML schema and grant execute to this group called Tiger team, only if the date hasn't passed a certain value. So ABAC will allow you to use dates in the access rules as well, which I think is going to be really useful for temporary access. And then ABAC use case number 3 is a great example of ABAC because it's not ABAC at all. Okay, so this is an example that I get often from customers. And here what we want to do is deny the ability for owners to manage permissions on objects. So there's this kind of fairly standard SQL pattern where you create an object, you're the owner, you can make grants on it. But what about if you don't want to do that because this is particularly sensitive data? So today, what you would do, there'd be a reasonable amount of catalog and schema design that you have to go into to kind of prevent this pattern from mattering. But what you'd actually be able to do in the future is to target this catalog called sensitive on the screen here and deny this privilege called manage grants to everyone except this hyper-privileged group called group 1. So this will remove the ability for anyone to manage permissions or grants on these objects except for this really privileged group. So this will be really useful. Okay, whistle-stop tour of access control. I think we have two more features. I put this one in last night because I spoke to a lot of customers about it this week. And there's going to be a new type of object in Unity Catalog, and that's called a cloud service. Now, why would you use a cloud service object? Let's say that you want to get access to AWS Secrets Manager or use SQS or SNS or an Azure service or GCP service. Well, Unity doesn't know how to natively model those objects yet. So let's take an example, perhaps Mert here. He wants to get access to Amazon's SQS, and he has an IAM role to do that. So what he can do, or we can do, is just register that IAM role as a cloud service in Unity, and then perform the grant in the top of the green writing here, so grant access on this SQS cred to Mert, and then he can go ahead and grab that credential in his code and access the SQS service. So in a nutshell, this cloud service object is this more arbitrary type of object that allows you to register something like an IAM role and then use it in your code. So lots of customers are thinking about using this for things like AWS Secrets Manager as well. Okay, the last one on access control, definitely not the least. You probably heard Matei's keynote earlier. We're really excited about the open source announcement for Unity. So the open source announcement this morning, you saw Matei press the button and launch the GitHub repo, which was pretty cool. And then the number one use case that I'm excited about here straight away is opening up the API interface. So with this new release, what you'll be able to do is use any of these different external tools and actually be able to access the objects that you have stored in Databricks in Unity, whether it's managed, external, it's a volume, it's a model, you'll be able to get access to it all. And we think that's really differentiated in the industry and really important as we work towards this open lakehouse as well. So go and check out the GitHub repo and the website that's at the top of this slide. Okay, so much more that I had to cut on the access control front. Group clusters for ML is also very, very close. I think the private preview is going to open up next week as well. Lots of people are asking about that. Okay, let's get into the second topic of today, which is search and discovery. Now, for those of you who are familiar with Databricks, You might be familiar with this screen. You saw Mert show it earlier. This is the Catalog Explorer. There's been a load of improvements to this year, circled on the screen here. I'm not going to go through them all. We're going to go into a demo really quickly. Just wanted to name three, my three favorite ones. So the first is AI-generated comments. So the AI will actually look at your table and suggest comments based on the metadata. I really like this because there's no excuse now not to have documented tables, and it makes the search better. Second, I'm kind of old school. I like ERD diagrams, entity relationship diagrams, because then I know how to join my different data sets together. And if you use the primary key, foreign key relationships in Delta, you can actually visualize that right in the Catalog Explorer here. Super useful. And then the third feature I wanted to point out is coming soon. It's just a couple of pixels on the screen here. You might not even be able to see it at the back there, but this is a quality health indicator. So if you start using Lakehouse monitoring, and that's detecting the quality of your tables, then this is going to start to feed into different surfaces in the UI. So as a user, you can see, if this table is in a good or bad state, and you'll be able to see it in things like Lineage as well. So those are three features that I really like. I'm going to pass over to Mert for a more full-fledged demo of some of the capabilities we released in the last 12 months.
Awesome. Thanks, Paul. All right, so I'm going to head back over to my Catalog Explorer. And for this demo, I'm going to take on the persona of somebody that's fairly new at Databricks. And I'm an analyst that's been tasked to do some analysis on our sales data for our company. And our company is selling various different kinds of apparel, think jackets, fleeces, scarves. And I want to find this table that has sales data for my jackets and see kind of what are our best sellers. So first of all, I'm going to start with our global search. I don't know the name of this table, but I know I'm looking for production jacket sales data. So I'm just going to type in jackets production here in the search and click enter. You can see from our new full page search that you can filter by types, and then based on the types, you can filter on a ton of other attributes. So I first see that there's the sales records table that comes up. And one thing to note here is that I searched up jackets production, but nowhere in the metadata for this table are the words jackets or production, but it semantically mapped that sweater is close enough to jackets, and it displayed this. This looks like this has our sweater sales record. So I'm going to go ahead and click on this. And I'm landed on the Catalog Explorer screen that we saw earlier. My eyes turn first at the comment, and I can see this has our sales data, and it looks like it's the right stuff. This has actually been generated using our AI-generated documentation feature, which takes into account all the metadata that you have about that asset in Unity. And it also generates column-level comments. So I'm going to go ahead and generate real quick some column-level comments based on all the metadata. And you can see it takes into account all the different constraints you've put in, the data types, things like that to infer this. Cool, so I'm going to go back to being kind of this person that's new to Databricks, and I found this data set, but I don't really trust it. I want to understand if folks are using this and if I should be using it. So I see there's this popularity indicator. And this comes from all the other queries that have been ran against this table in Unity. And I see this has been queried quite a few times in the last 30 days. But I want to know even more about who's querying it, how it's being queried. So I have some kind of insight into how I should be using it. So I'm going to click on the Insights tab here. And what you'll see is it shows me kind of the usage over time of this table, as well as some really interesting things. So one, I can see the frequently used notebooks where this table is being used, the frequent dashboards. And I can click into these and see other people's code, which is super useful because I can just kind of rip it and use it as my own. It also tells me some frequent queries that other folks have been running. So these are all the SQL queries. And it's like a personal kind of Stack Overflow for each table that I can see in Unity. And if I have any questions, I can see the most frequent users. So it looks like Roderick's been querying this table a lot. So I can reach out to him if I have any questions on the data. Another cool thing is we capture all the frequent joins that this table has been used with. So I can see the store, product, and customer tables are frequently joined with the sales records. But I want to go even a step further. I don't know the primary key, foreign key relationships with these tables. And I want to make my job easier to understand how I should be joining it with these other tables that it shows me. So I'm going to go back to our Overview tab. And I see that in Unity, we've actually marked the primary key, foreign key constraints. And like Paul showed earlier, will automatically generate an ERD diagram based on this. So I'm going to go ahead and click the View Relationships button. And here it shows me the product, customers, and store tables that we saw were frequently joined with. And now I know exactly the keys that I should be joining these on. Cool. So now I kind of found the right data. I understand it. I know which tables to join it with. I have some insights. I have some code to get started. But I'm still left with one last question, which is, besides Roderick, is anybody else using this table? Is it being updated? Is it maintained? So I'm going to head over to the Quality tab, which is powered by Lakehouse Monitoring. And I'm going to click on the auto-generated dashboard that Lakehouse Monitoring generates based on the data. So it's going to take a second to load. And this tells me a few things right off the bat, which are super useful. One, it tells me that there's no columns with high amount of zeros or nulls, so it seems like the quality of this table is pretty good. And I can see over time that the row count is increasing, and it's been fairly recently updated. So this gives me good confidence in terms of this table is being maintained, and if I'm using it to get certified data, it should be pretty accurate. Cool. So in this demo, I was able to discover a table that I didn't know the name of, understand kind of insights on how this data is being queried, figure out what other tables I should be joining it with to get insights, and then also trust the data's quality by seeing the Lakehouse Monitoring dashboard. Awesome. I'll hand it back over to Paul to talk more about our discovery roadmap.
Fantastic. So what's up next for discovery? The first one we're very, very passionate about is request for access. So the goal here is you want to make sure your users can get access to the data they need. Okay, that's the simple task. So there's going to be a 3-step process by which we do this. The first thing, which you can actually go home and do today, is start by making your metadata discoverable. Okay, so we recently introduced this new privilege called Browse that allows users to see the metadata for objects and see the lineage and search for them without being able to actually query the underlying data. So there's very low security risk to give people access to the metadata, and most folks are going to do this very widely based on conversations we've had. So go home, make your metadata discoverable in your Unity catalog. Because once you've done that, the feature that we're currently working on is the ability on a catalog or schema to actually set what we call a request for access destination, which is a bit of a mouthful. But essentially what this means is if someone requests for access to an asset in your schema, where should we send that request to? So the options that you see on the screen here, you'll be able to set an email address or a Slack destination. You'll even be able to do integrations with Jira and ServiceNow or your own ITSM. And then what will happen, users will come into the product and wherever they see data, like in the schema browser here, they'll be able to right-click and say, I want to access that thing. And the admin will be sent the request at the destination you configured in step 2. So we really think this will shorten the cycle and allow your users to get access to the data in a much more seamless way. So we're really excited about this. Next, last one on discovery, teased by Matej in the keynote this morning, is metrics. So how should we think about metrics? So you've got your bronze, silver, gold layers, right? You're curating your different data. Well, metrics is almost like a platinum level of your data. And what you do here is you kind of include the instruction manual with the data itself. So as a curator, data steward, what you'll do is you'll take this data, you'll define what the dimensions are, what the grains are, and things like that, provide rich metadata for it, and it will make it super easy for your users to go and then query this data because they'll know exactly how they're supposed to slice and dice it. We're building this in an AI-first way so that all of those AI assistants will be able to understand it. So we really think this will be a great way for your business users to get more involved with the data as well. And essentially, from a discovery point of view, know which table they should be using as well, because it will come with some certification metrics. Cool, so that's the discovery topic. Last one, probably my personal favorite, Lineage. So 3 things you should know about Lineage, and then we're going to actually do a live demo of this. So firstly, we collect lineage in an automatic and real-time way. So your users just write queries, and we infer what the lineage should be. It works at SQL, Python, Scala, and down to the column level as well. And we do it across many different types of assets. So it might be a bit small to see on the screen here, but on the diagram, you actually have files in volumes, you have tables, you have a federated table actually from Postgres in this diagram. The newest one was models, so you can actually see which data was used to train a model. Really soon we'll be linking serving endpoints to this as well, so you'll be able to see how your models are being used in different endpoints. And there's one new thing in this diagram which I'm not going to reveal, and I'm going to let Mert demo that live here as well. So I'm going to pass it over to Mert to do the final demo of the session on Lineage.
Awesome. Thanks, Paul. All right, so I'll do a quick demo on Lineage. And so I'm going to enter into a notebook. And let me give some context. I'll be running some cells, and my goal is to train a new MLflow model. And as I run these cells and train this model, it'll generate all the different kinds of lineage that Paul mentioned. So I'm going to start out by just creating a volume. And just as a quick refresher, that's just a container to hold structured and unstructured data. And I'm going to load in some data from my cloud object storage. So the first step in training my MLflow model, I'm going to create a feature table. And I'm going to load in some data that I've staged in my volume, which brought in data from some my cloud object storage. And also I'm going to add some data in that I've federated into Unity from Postgres. So you can see on my left nav here that my Postgres tables are federated into Unity using the Lakehouse federation capability that Paul mentioned we went GA with earlier. And I'm just going to run to load in the volume into this table called feature table. And then I'll also add some data from my federated Postgres source. And just in a second, it now generated this table. Cool. So I'm going to refresh this, and I'm going to head over to the Catalog Explorer to see the lineage that's been generated in real time. So it's immediately generated into the Lineage tab. I'm going to open up my Lineage graph, and you can see my Postgres source and my Databricks volume are upstream of this feature table that I created. Cool. So I'm going to head back to my notebook, and now I'm going to train an MLflow model from this feature table. So I'm going to start by importing some libraries, and I'm going to split up my data in my feature table into training and test sets. And I'm going to start my MLflow run. So a couple things to note here. So I'm writing this line of code to register my model into UC, and this will allow the lineage to be automatically inferred for the model. And then I'm registering this as a version of the model. And what I'll also do is I'll train a second version of the model, very similar to the first one, but for this one I'll use a different feature table that I have from a different table. And once this runs, cool. Now I'll head back over to the same Lineage tab. And in real time, I trained this model, and I'm just going to refresh it, and hopefully it will now generate the model lineage. Cool. So you can see here that it shows that this model was trained from this feature table, and I can see different metadata for it. You can see it was captured from the notebook that I just ran, and the table is upstream of it. What's really cool is I trained that second version of the model, and I can flip between it. And I can see the full lineage for that version of the model as well, which actually comes from a different data set, which has different upstream gold and silver and bronze layers. So in just a few seconds, I was able to train this model and see the full lineage for it and flip between the different model versions. Cool. So I'm going to head back over to the lineage. And so one of the biggest feature requests that we've had over the last year is our auto-generated lineage is great, but folks want to be able to bring their own custom lineage metadata and add it into Unity so they can get that end-to-end lineage view. So I'm really excited to announce we have a private preview out right now for Bring Your Own Lineage. And this allows adding that custom first and last mile metadata, so you can see that end-to-end lineage, even if the ETL happens outside of Databricks, or in the last mile case, if you have Tableau or Power BI dashboards that are reading from lineage. So I'm going to go ahead and do this in real time, and I'm going to add some custom first mile lineage. So it turns out that prior to the data that I loaded from S3, this data came from a Salesforce object, and I want to be able to show this relationship in my Databricks lineage. So I'm going to import some libraries really quickly. And I'll call our bring your own lineage CRUD APIs to create a new custom entity with some metadata from the Salesforce object. So this is an accounts object, and I put in some properties, metadata here, and I specified that it's upstream of this Databricks volume. And then similarly, I'm going to run our same APIs to add some last mile lineage. So it turns out that we have this Databricks table, and it powers a dashboard in Tableau, which our executives rely on to get insights. And any kind of schema changes with this table will potentially have downstream impact outside of Databricks. So I want to be able to map this in lineage so users, when they come into Unity, can know that there's dependencies outside here. So once again, I'm going to similarly add this new entity type as a custom entity for Tableau, and I'm going to put in some metadata, and I'm going to specify that it's upstream. It's a downstream dependency of the feature table that I was showing earlier. Cool. So now that I've ran this, I'm going to head back over to the Catalog Explorer, and I'm going to refresh my screen. And now when I go into the Lineage tab, it not only shows me all the auto-generated lineage that was inferred from me training the model, but now I can also see this last mile Tableau dashboard and the metadata that I added right in Unity. And then similarly, upstream of my volume, I added the Salesforce objects to show the metadata of this upstream dependency, and I can see the metadata all here in one place. So to quick recap, I was able to generate lineage from a federated Postgres source, combine it with some data in a file, and it shows up in lineage as upstream of this feature table. I trained a model on it, and I trained multiple versions, and I can see different lineage for those. And then lastly, using our new bring your own lineage capabilities, I was able to add in this custom metadata to get that end-to-end view before and after Databricks. Awesome. I'll hand it back over to Paul.
Excellent. So that just about wraps up our session. We looked at these three things today. So in access control, search and discovery, and lineage. Hope you enjoyed the session. We'll just point out there's a few of the features here that are already in private preview. So if you're interested in Hive Federation, the service credentials, bring your own lineage, or assigns group clusters, those are in private preview. So contact your account teams to get enrolled. Just leave you with this. Enjoy the rest of the conference. We'll be waiting at the front of the stage for any questions today. So really, thank you for being a great crowd, and enjoy the rest of the conference.